This is section 2.2, and it's about linear models, equations, and inequalities. So first thing I want to talk about, something that you've already seen in your algebra classes in the past, is correlation, whether it's positive, negative, strong, weak, or no correlation. So a positive correlation would look like this. It'd be going up, and there would be a correlation in data points. A negative correlation would look like this, going down. A strong correlation would have the R squared value would actually be more than 0.8, and a weak correlation would be that R squared value would be less than 0.8. No correlation would be in between, so a graph that had no correlation would be a graph that looks like this. You couldn't put a line anywhere that would make sense, that would make these dots look like they're going in a line like those. And correlation has a lot. It has to do with the R squared value. And if the R squared value is 1, it is a perfect line versus all the way going down to 0. So basically it's saying that the data strongly represents a certain curve. It could be a line, it could be a quadratic, it could be cubic, it could be exponential. So it just follows really closely to a certain type of equation. And when the R squared value is high, close to 1, that means you can make good predictions. All right, so let's take a look at this first one here. Make a scatter plot of this data on your calculator. Then find the linear function that fits the data. So on this one, we're trying to find a linear function. So if I were to enter this stuff into my calculator, this would be my L1, this would be my L2. We've already done this, so this should be a little bit familiar to you. So, and then to find a linear regression, we're going to put this in, we're going to go from stat, enter. And then we're going to put those in the list just to give you an overview. And then I'm going to take my stats and I'm going to calculate a linear regression. And that is going to give me my equation rounded to the nearest thousands. And then if you find the R squared value, and if it's not on there, you need to go into your menu or your catalog and turn your diagnostic on, and then push enter so it shows that it's on, and that will get you your R squared value. So let's take a look and do that really quick. So we're going to go into stat, enter. I'm going to clear out the lists that are already there, go over, I'm going to go up, I'm going to push clear, I'm going to come back down, and then I'm going to enter these numbers. So I have an 11, 8, 5, 2, and -1. And make sure you push enter after the last one. Oops. And -1, I have to do down here, not my keyboard. Okay, and then the next one is going to be -5, -3, -1, 1, and 3. And make sure again that you push enter. Notice the 3 is not populated in there yet. You have to push enter for it to do that. And then I want to find, I'm not worried about the graph at all on this. All I'm doing right now is finding this equation that is the closest fit to here. So I want to make sure that my R squared is on. So I would go to my catalog and then I'd scroll down to the diagnostic on. Hopefully mine's on. So I'm going to do stat, calculate. I'm going to calculate this linear regression here. And I'm just going to scroll through these because my L1 and L2 are there. And my R squared isn't on. It should populate right there. So I'm going to have to go in and get it out of the catalog and turn my diagnostic on. So I have to basically do this very annoying step, which is scrolling down to the diagnostic on. And the diagnostic on is right there. So I'm just going to push enter. And I'm going to push enter one more time. Make sure that's on. Now I'm going to go back and do my take my stats. I'm going to calculate that line of regression. I'm going to move through this so it's tabulating it as it goes. And it's right there. So here's my equation. So I'm going to write y equals negative 0.667 because I'm rounding it, x plus the b, which is 2.333. So I'm going to go ahead and put that right here. And y equals, and you should know that 0.6 repeating is 2/3 and 0.3 repeating is 1/3, so you can make those exact. So ones like that, you should be able to use your number sense to put those. And notice that the r squared is 1 on there. So I'm going to have negative 2/3 exactly, so I'm not going to round that, x plus 2 and 1/3. And my r squared value is 1. And that's what I noticed. So this is actually linear. It's a perfect line. If you were to plot those, it's going to be perfectly in line. It's going to make a line. Next one, make a scatter plot of the data, then find the linear function. So again, noticing it asking for linear. And then find the r squared value. What do you notice? And then I want you to find f of 5. So if you want to pause your calculator right now and put that in your calculator, that would be great. So I put those in my calculator, and now I'm going to take the stats. I'm going to calculate number 4, which is a linear regression. I'm going to let the calculator do the work for me. And here is my equation. So the a is going to go in front of the x, and the b is my y-intercept. And look at the r squared value is 0.6305. So I'm going to go back and write that on my here. So I've got y equals negative 1.3 x plus 7.2, and the r squared is 0.6306. So in this case, these are not so lined up. And to find f of 5, I'm going to show you another thing on the calculator. So it's going to be stat. In fact, I'm just going to go on there and do it for you. I want to find where this calculates a value actually we're not going to do it that way. Let me go back to here. We're going to take our 5 and we're actually just going to drop it right there to find 0.7. So we're not going to do that on this one. All right, next one, a little bit longer problem here, but the proportion of those convicted in federal court who are imprisoned have been increasing. The table shows the number of those imprisoned for selected years from 1980 to 2007. So here is my L1, here is my L2, and it says that it shows from 1980, so that's going to be my year 0. So this is actually, when I put it in my calculator, year 0, year 5, 10, 15, 20, 25, and this last one is 26. It's only 1 year difference there. So you're going to enter the data into your graphing calculator and calculate the line of best fit. So we're going to do that first, and I'm going to pause and get this in my calculator first. So I entered into L1 all of the years in terms of x equals 0. Notice that these last 3 don't go by 5s, and just for future reference, I think it's in this homework actually, it doesn't have to start at 0 either. If year 0 was 2000 and the first year was 2003, this number would be 3. So it's not necessarily that that starts at 0, so make sure you read your problem carefully. And then I put in the number imprisoned on the L2, and now I need to fix my window so I'm able to see these. So I'm going to go from 0 to 30. I looked at my x's to see this. So 0 to 30. And then my y's, I'm going to go from 0 to, our highest one is 62,000, so I'll probably go to 70,000, just so that all my points end up in there. So 0 to 30 and 0 to 70,000. And I'm going to go ahead and graph that. And notice nothing graphed, so I need to go back to the y equal. If I wanted it to graph, I'd have to clear these out, and I'd have to put my plot on. So I'm just going to do that. I know that I don't think the problem asked for that, but just to give you a little extra practice, because this will be on your test. That's what it plots out to be. So the question then, going back to your sheet, enter the data into the calculator. We did that. Calculate the line of best fit. So if I go back to my calculator, I'm going to take my stats. I'm going to calculate, so I'm going to move over one, and I'm going to do my line of best fit, my number 4 there. And I'm going to enter through this. And it gives me my, my A and my B and my R squared. So I'm going to go ahead and write that on my sheet here. So I've got y equals and I'm rounding to the nearest thousandths again, because that's my default. Zero, because that 9 goes up to a 0 because this is a 6, and then this 0 stays a 0 because that's a 2. So just to refresh you on the rounding part. So that's that answer. And then use your model. So use your model, and the model in this case again is the equation. So use your model to estimate the number in prison in 2002. So in 2002, that ends up to be x equals, so I would go 2002 minus my year 0, which is 1980, and that ends up to be year 22. So now I'm going to take that 22, and I'm going to drop it right here and plug that into my calculator. And when I do that, I end up with about 53,350 prisoners. So I am making a prediction here that in 2002, which would be somewhere in the middle here, right, I'd have about 53,350 prisoners. And that's the whole point of finding this line of best fit, or this regression line. My last thing that I'm going to do on this problem is use your model to determine in what year the number will be 78,750 prisoners. So this one is the Y, because the Y is the number of prisoners. So I'm going to take this one, I'm going to put it here. So I would have that number equals the equation. And being that this is just linear, you're going to go ahead and solve this just algebraically instead of doing y1, y2. So if you solve this algebraically, you would subtract that 10,000 and then you from this, and then you would divide by the 1900. And if you did that, you would get x is approximately, I'm just going to put equal here, 35 point, and it ends up to be, 4 zeros and a 2, so we're just going to round it to 35.0. So it's really in the very beginning of year 35. So year 35, how do I find that? I would take 1980, my year 0. By the way, I changed that to a 6. 1980 plus the 35 to get me 2015. So this is a really good problem. It shows you how to enter raw data from a table to regress to this line of best fit. And this skill will help you all year because we're going to find exponential line of best fit. We're going to find quadratic. So we're going to expand on this, but make sure that you know how to do this part here, finding this equation, line of regression, finding if I gave you the x, could you find the y? And if I gave you the y, could you find the x? So those skills you're going to be expounding on all year. And here is your homework.